Okay, pre-calc. So the second half of chapter 4 is going to be a lot about graphing trig functions. So both 4.5 and 4.6. We're going to do those together, but over two parts still. And then they are going to be all about graphing functions. 4.7 we'll start to talk about inverse functions again, which we've talked briefly about. And then 4.8 will be about solving trig equations. Okay, so 4.5 and 4.6 part 1. We're going to look really briefly at the graph of sine and the graph of cosine, and we'll get into more detail about them in school and how we can develop them. And then we're going to talk, the heart of this video is going to be about something called amplitude and vertical shift. Okay, so real quick, the graph of sine, so this is y equals sine of x. You may see f of x equals sine of x, and this is only one period. Okay, now when we start to talk about periods, it means that our functions are going to repeat themselves over and over and over and over. So maybe a better graph than this even would be y equals sine of x like we have here. So if I zoom out a little bit, you see that the function is just repeating itself over and over. So we have like from 0, and it repeats itself at 2 pi. It starts to repeat itself again. At 4 pi, it's repeating itself. And the same going the other way. At negative 2 pi, it's starting to repeat itself again. So it's just a wave. We call it an oscillating wave. It's going back and forth with itself over and over and over. Now, we're going to talk a lot about just one period and how the graph is affected by that. So what you want to look at is x-intercepts, and there are 3 x-intercepts here at 0, 0, pi 0, and 2 pi 0. And then there's a maximum here at pi over 2 and 1, and a minimum here at 3 pi over 2 and negative 1. Okay? Now, the other big thing that you've probably noticed by now is that our x's are not in our traditional integer values, but we're actually looking at values that you might see on a unit circle, or really our x is going to be in radian values. Okay, now cosine is very similar, except for, and it's going to be repeating over and over and over, but now there's only going to be 2 x-intercepts, and you see an x-intercept here at pi over 2 and 0 and 3 pi over 2 at 0. There are 2 maximums at 0, 1 and 2 pi 1, and there is a minimum at pi negative 1. Okay, so that kind of identifies those 3 parts right there. And those are going to be key points that we're going to use over and over and over. Okay, now, every trig function, so here we have sine. We're really only going to look at cosine and sine. I just put sine in here just for simplicity's sake. But there's going to be 4 values we're looking for, A, B, C, and D here. And they each do something different to the graph. So we have done transformations like this before with our parent functions in first semester. Same idea here. A is going to be something called the amplitude. B is going to affect something called the period length, meaning how long that period is. And traditionally our periods are 2 pi. And it's also going to have something to do with phase shift, or it can. And C is going to be a phase shift. D then is finally what's going to be called a vertical shift. Okay, so a phase shift sounds weird. A phase shift just means it moves the graph left to right. So it's kind of like a horizontal shift, but since the graph goes in both directions forever, we give it a different name as a phase shift. Okay, so what amplitude does, that is going to change the vertical. It's like a vertical stretch. It determines the max and min of the graph. So it's another way to think about this is a vertical stretch. Okay, so it's like pulling it away from the x-axis traditionally. And then we have the vertical shift. And so amplitude, we already said in that previous slide, that's going to be A, and our vertical shift is going to be D. And the vertical shift is just moving all of the points up and down. So if D is a positive number, if we're adding D, we go up. And if D is a negative number, we go down. Okay, so that's the 2 things that this video is really going to look about. Now, to give you a better idea of what I mean by amplitude and phase shift. So if I take my graph here, I'm going to do y equals sine of x again, but I want to change it. I don't want it to just be sine of x. I'm going to say let's add an amplitude in of 2. Well, then you can see right here is what happens. Our maxes get higher, so all the maxes got higher, and our minimums, our lowest values, all got lower. But notice nothing happened to those x-intercepts. They stayed right where they were. And the graph is still repeating itself over and over and over and over. Okay? And we could do anything we wanted. Like we could say 4 here, and it gets really high. We can make it a fraction. Instead of it getting bigger, so like 1 over 4, it would actually, you see, get lower. So our maximums get closer into the x, our minimums get closer into the x. Okay, so that would be if we were doing an amplitude change. Now let's say that we're doing a vertical shift. So like we said, if it's plus, we go up. So plus 2, you see every point went up. It wasn't just the max or mins. And likewise, if I just change that to a minus 2, we go down. Okay, and so every point moved down to. And it wouldn't matter what function you did here. We could change this to cosine, and then change this also to cosine, and you see it's the same idea. So the graph looks a little bit different because it's cosine now instead of sine, but it still does the same thing. We have negative 2 as a shift down. Now we could also do both at the same time. So let's say that we have a 3 cosine negative 2. So let's start. We start with a 3 times cosine. Everything gets, maxes get higher, mins get lower, it stretches the graph vertically. And then if I wanted to subtract, let's say 1, so everything shifted down 1. And maybe, actually, I can even show you this. So you see it a little bit different. 1 times 3 cosine of x. So we've got that same graph, and now we're shifting it down 1. And so that orange graph shifted down 1. Okay, and we'll talk about order of operations because it is important how we apply those. All right, but that is it for this lesson. Biggest thing, amplitude is going to change your max and min. It's like a vertical stretch. So it pulls everything away from the x-axis. And the vertical shift, if it's positive, it moves up. If it's negative, it moves down.